Third question. A body is falling freely under gravity. Suppose the distance s it falls depends on the acceleration due to gravity g and the time t for which it has been falling. Using dimensional analysis, derive the expression for the distance s in terms of g and t. So it is a question on deducing relations using dimensional analysis. We have learned this. So such type of questions will come for the exam. It's given you have to derive an expression for the distance s based on the factors which it depends. It's giving us two factors which it depends on g and t. Okay, so here's the scenario. The body is free falling from a point h, height h, under the force of gravity. The distance s, suppose this is the ground, so the distance s which it has covered depends on the force of gravity g, acceleration due to gravity g, and the time taken for it to reach the ground. Okay, so let's write this in mathematical form. S is dependent on, so we put the proportionality sign. S is dependent on g and t, right? And we don't know by how much it really depends on these factors, so we put the variables a and b, right? And to remove the proportionality sign, we put a proportionality constant. So s is equal to k times g raised to a and t raised to b. We know k is just a proportionality constant, and when we write this in terms of dimensions, k, we don't have to write k because it's a dimensionless constant. So s is length L, g is acceleration due to gravity, so acceleration L t raised to minus 2 raised to a, time is t raised to b. If we solve this, L raised to a, t raised to minus 2a plus b, right? Minus 2a plus b. And on this side we don't have a t, so we introduce a t here by giving it 0 dimensions, so L t raised to 0. Now we see L raised to 1 and L raised to a, so we can assume that a is equal to 1, right, by equating the exponents. And from here t minus 2a plus b is equal to 0. We know a is 1, so we substitute that there. Minus 2 plus b is equal to 0, so b is equal to 2, right? We got a and b. We substitute in this equation. This is our equation 1. We substitute these two variables in equation 1, so that will give us s is equal to k times g raised to 1 t raised to 2, right? So we got, this is the final equation, k g t square. Okay, so this is the required answer. Now for your understanding, I'll give you the proper expression for this was half gt square. Okay, but we know that we cannot find dimensionless constants like half, 1 and other such constants using dimensional analysis, so we can stop at kgt square. This is the correct answer. But it is another question on deriving expression using dimensional analysis. The speed v of a wave traveling along a stretched string depends on the tension T in the string and the mass per unit length mu of the string. Using the dimensions method, derive the expression for v in terms of T and mu. So what is given? We have to find the expression for the speed v of a wave traveling along a stretched string. So suppose, I'll explain the concept. This is a rigid support where a string is attached. Okay, we know when we attach a string and give it a quick jerk, a wave will be produced, right? A wave like this will be produced, which will move along the string in the direction which you jerk it to. So it will go up to here and then travel back, and then it will eventually fade out, right? So we have to find the velocity of this wave, and we know the velocity of the wave depends on the tension. Tension means the force acting opposite to the rigid support. So T is the tension. It's just a force, so we can give it the unit Newton. Okay, so T tension means a force which acts in the opposite direction of the rigid support. T tension of the string and the mass per unit length of the string. So mass per unit length means we know the string has a mass. It's not given it's a massless string. It has a mass, and the string, the mass per unit length ratio is means the mass of the string divided by the length of the string. This would give us a new unit called mass per length, which is denoted by the Greek letter mu. So our velocity of the string depends on two factors: tension of the string and the mass per unit length of the string. Okay, so we can write velocity of string depends on proportionality, depends on T, tension of the string, and mu, right? And to remove the proportionality sign, we put a proportionality constant T, and we don't know how much it depends on, so B, A and B, letter B are variables, right? This is our equation 1. Now we derive this in dimensions. V is velocity, so Lt raised to minus 1. We don't write K, it's a dimensionless constant. T means tension, which is a force. So force is mass into acceleration. So mass into acceleration, we can write M L T raised to minus 2 raised to A. Mu is mass per length, mass divided by length. So mass divided by length, so minus 1 raised to B. Solving this, we get M raised to A plus B, L raised to A minus B, and T raised to minus 2A, right? And here also we don't have M, let's just put a 0 dimension for that. L 1 T raised to minus 1. Okay, now equating the exponents M and M, 0 A plus B, so A plus B is equal to 0, first equation. For L, A minus B is equal to 1, T minus 2A is equal to minus 1. So the easiest to solve in these equations would be this last one. So we can solve that A is equal to 1 by 2. Okay, so putting this equation here, 1 by 2 minus B is equal to 1. So B is equal to negative half, right? And if we want, we can verify it using this. A is half, B is negative half. So half minus half is 0. So we indeed got the right variables. Now substituting these variables in 1, we get V is equal to K T raised to half mu raised to minus half. So we can write the final equation. V is equal to K, half is just a root, so root of T divided by mu, right? This is our derived expression. Question: the escape velocity v of a body from the surface of a planet depends on the gravitational constant g, the mass of the planet m, and the radius of the planet r. Using dimensional analysis, derive the expression for escape velocity v in terms of g, m, and r. Okay, so what is escape velocity? You will learn it in gravitation, but I'll just give a gist of it. Suppose this is our planet, right? This is a ball which I want to throw outside of this planet such that it is not affected by the force of gravity of this planet anymore. So we have to throw the ball at a certain velocity v such that it escapes the force of gravity of this planet and goes to infinity, right? So such a velocity is called escape velocity. Escape velocity is what? The velocity required to propel a body outside of the force of gravity of a planet. You just understand that much. And this velocity is given to be depending on the gravitational constant g of the planet. G is gravitational constant of the planet. Mass of the planet m. M is the mass of the planet, and radius of the planet r. Radius of the planet r. Okay. So if we were to write it, v is directly proportional to g raised to a, m raised to b, r raised to c. So velocity is equal to proportionality constant k, or any other letter. It doesn't exactly have to be k, but by standards it's k, g raised to a, m raised to b, r raised to c. So this is our equation 1. Now writing it in form of dimensions. So v is L t raised to minus 1. So L velocity L t raised to minus 1. K is a dimensionless constant. Capital G is a gravitational constant. So in case you don't know the dimensional formula of capital G, you can derive it using the force of gravitation expression given by Newton. So we all know this expression, F is equal to G m lowercase m by r square, right? This is used to give the force of attraction between two objects. Okay, and suppose to find this G, you will cross multiply everything to the other side. So F r square divided by mm, right? Force is what? Force is m L t raised to minus 2. R is L square. M is m times m. So we can, if we solve this, we get the dimensional value of G as m minus 1, m raised to minus 1, L cube t raised to minus 2. Okay, so this is how we actually, if we know the relations, it's easy to find the dimensions. So G, we don't write k, it's dimensionless. So G is m minus 1 L cube t raised to minus 2. Okay, m is mass itself, b, r is length, radius is length raised to c. Solving this, we get m minus a plus b L 3a plus c t minus 2a, right? Here we write m raised to 0, L1 t raised to minus 1. Now we equate the exponents. So b minus a is equal to 0, 3a plus c is equal to 1, minus 2a is equal to minus 1. Solving a first, because it has only one variable, a is equal to 1 by 2. Putting a in this, b minus 1 by 2 is equal to 0, b is equal to 1 by 2. So we found a, we found b. Now for c, c plus 3 by 2 is equal to 1. So c is equal to minus half, right? So we found a, b and c. Putting in this equation 1, we get b is equal to k g raised to half m raised to half c raised to r raised to negative half, right? So everything is under half, but r is in the denominator. So k root of g m by r. So this is our final equation. So this much is needed for the exam. But if we are talking about the real equation goes v is equal to root of 2g m by r. Okay, our k was root 2, but we couldn't find that using dimensional analysis. So the actual formula is root 2 times root of g m by r, but here this is enough. So that was it with our questions. See you in the next class.